Hello and welcome to another tutorial. We are looking at using the var type identifier, and we said that var is not designated as a keyword. It's a reserved word in the context of local scopes, not global scopes in classes, right? And we said that var means a type identifier, so we're telling the compiler, I don't care what the type of this variable on the left hand side of the assignment is, you go ahead and figure it out, right? And that only works in the scope of local variables. We said that, but this doesn't apply to type of parameters of the methods. You cannot use var with the types of like the parameters of a method when you declare and define a method in a class. That's just because that can cause confusion for the compiler. So in doing so, you let the compiler decide what is the real type of the variable you create, right? And this works in the context of the assignment. And we said that you cannot just var works in the context of the assignment. What this means is that, so let me just type it in the context of assignment, which means you cannot just declare var x1, or maybe we already defined x1 somewhere, let's say v1. You cannot do this. You cannot just leave it uninitialized. You cannot leave it uninitialized, because then the compiler is very much confused. What is this? I mean, there is no hint to the compiler that what's going on with this variable, right? So you kind of need to initialize it so that the compiler can look at the right hand side, let's say 2.5. And now the compiler can, okay, right hand side, I can figure out what the type is, and var just means you want me, the compiler, to deduce the type here. And obviously if we do this, var is going to be a double, right? So sysout v1, for example, and if you look at the type of v1 is inferred as double. So you cannot just leave it uninitialized, because then the compiler has no clue. So var just means we're telling the compiler you deduce the type, but then you have to give it enough hints to the compiler so that compiler can be able to deduce the type. And same with the like interfaces, lambda expressions. We said that lambda expressions are anonymous functions. They by themselves don't define a type, right? Or even a method reference. But these lambda expressions or method reference, they are allowed to bind to certain type of interfaces. Remember, interfaces and classes, they define types for variables, whereas a lambda expression doesn't define any type, but it can bind to a certain type of types, interfaces or classes. And we said that basically functional interfaces are a beautiful way of using Java for defining mathematical functions, and it's very beautiful. You can just define your type or function in one line, and we know that I cannot use var here with the lambda expression, because the lambda expression doesn't define any type, but it allows to bind to a type. So a lambda expression can bind to the variable of the type functional interface math function. Same here. However, we said that for anonymous classes, it's actually possible to because anonymous classes, you have to explicitly call the new operator, and therefore there is no problem with the compiler to look at the right hand side, and compiler says, oh, I know what the type of the right hand side is. You're calling the new, which means you're creating a type, some sort of type. Here in this case it's a math function interface. The compiler deduces that func3 is basically at this point, as you can see, actually if I zoom in, you see the compiler still uses var here. Eclipse shows var, so if I go back here, it still shows var here. So it's interesting that you can use var with func3 here, but Eclipse doesn't really show the actual type here, right? All right, back to the documentation. So we know that Java is statically typed, so you have to, whenever you have a variable in Java, all variables are either pointers, which means references, right? References are just syntactic sugars for pointers, and then primitives. So primitives is obviously easy to deal with. References or pointers to objects, then you have to then define the type. And we said that Java tends to be verbose just for better code readability in the source code, which means you want to type all the names and you want to stay away from abbreviating names. For example, you want to type input stream instead of saying that INPTSTR, for example. Now obviously this is not the convention that you see in Java or you see in C++ or Python. They tend to abbreviate, especially in C++ libraries, but in Java we want to be verbose so that the code is very much readable to the human user, right? So, and then we said that sometimes it's very difficult because the names are long and we don't want to bother with typing them. IDEs can help a lot. And now that with the introduction of var, it also makes life much easier, because we say that, okay, compiler, as long as you can infer the type on the right hand side, just give me a variable with that name that is a reference to that object. I mean, it doesn't make any confusion, because any human that reads this line, it automatically knows what the type is going to be. It's input stream. When you say new input stream, it's very much telling. And these are really the best practices of programming, which Java really put a heavy emphasis on. And now, as I mentioned before, for example, if you look at this line of code, now we have to also define the path. So let's say I say from wherever you are, we know that when we launch the, let's import the path from Java NIO and import the files, right? So and this throws exception. Let's try it with catch it with try catch, right? Now at the moment not everything works. Var, this path has been a deduced path, and it's just the compiler knows that the return type of is a path, so this path is this variable path is of type path, right? There is no confusion here. Same with the new input stream. The compiler knows that it returns an input stream, and therefore the type of, so these things are very easy for compiler to deduce using the var type, and it's very easy for us to type. And in the past, the way I did it, I used Eclipse feature, and I mentioned this in the previous lecture, that I used to do this. Instead of declaring the left hand side, I first declare the right hand side and use the var code template that Eclipse provides. And this one doesn't work that well, right? So this sometimes works, sometimes doesn't work. So if I say var, it messes up. I don't know why it goes there. It's not working that well, right? But usually this code template, let me see if I can create a local scope, for example, and see if this works. No, it doesn't work. So sometimes this var template of the Eclipse works, sometimes it doesn't work. But now with using the var type identifier of the JDK, it's very easy to deal with this type, because I mean these are local variables. We're just going to use them in these few lines of code, and then we're not passing them around, so there's no point in trying to be very verbose here, right? You can be, but there is no point for local variables, because you just use them locally and then dispose of them. All right, examples with var. The following example shows you how you can use the var type identifier. Remember, note that they don't say var keyword. They say var type identifier, because var is not a reserved keyword as per Java language specification. To make your code simpler to read, here the strings variable is given the type list of a string, and the element variable the type a string. So list of, we're using the static method inside the list interface, which they added from I believe Java 8 or Java 11, I'm not sure, or maybe Java 9. At some point they added the support for static methods in interfaces, and they started adding these static factory method, and these I believe return immutable lists. You can try that and see if it's actually immutable or not. For var element, so we're using a for each loop, and again we said that var also works in the context of for each loops, because, or in the context of for loops, because these are still local variables, right? So if you just want to create a list and iterate, you don't really care, and let's say print them as a string, and you know that any type has some sort of toString, and so println knows how to deal with reference types or primitive types. So we don't really bother in this case with the type of variables, because it's just local variables. On this example, the path variable is of type path and the stream variable is of type input stream. So again, you can use, even in the context of try with resources, you can use try with resources so that you close the stream. So here obviously as whenever you open up create a stream, it means it's open and ready to use. And eventually you want to have a, for example, finally, so that you can say a stream dot close. Okay, it's looks like it's not busy, so maybe we have to close it, I guess. If we want to know that we're declaring this stream here locally, which means the scope is limited to the try block, that's why it wasn't available in the final block. And if we want this to be available in the final block, we have to declare it outside. And as I mentioned before, you cannot say var a stream because the compiler has to know the type. But so we kind of are forced to declare this type here, and then go like this, and then eventually in the finally try to close it, right? But this can also throw exceptions, so it gets complicated. So the best solution is to basically go with try with resources. So I'm going to copy this line, let's comment this, and then say try, and then do whatever, and it automatically handles finally. If any exception is thrown in finally, it's going to work. So we're going to var stream equals files new input stream, right? And it's going to throw exceptions, so we're going to catch them. So maybe let's remove all this code and try to catch them. Yeah. And now again, this stream is now the type is deduce input stream. So var works for even the we don't need to have a semicolon here. This var works for local type inference, even in the blocks such as try or for loops. So let's say I want to declare a for loop. For typically we say int equals I equals 0, I less than, let's say 10 I plus plus, go do something, sys out hello, right? Now the question is, can I use var here? And the answer is yes, because the compiler looks at the right hand side and sees that it's an integer. Remember, the default type for integer literals, decimal literals is int. So I is automatically deduced to be int type. So you can even use var here, that's fine. I can even say var length len equals 10. Actually, we don't need to use the var twice, and I less than len. Now this doesn't work. Why? Var is not allowed in a compound declaration. What this means is that typically when we declare Java allows to declare multiple variables of the same type in one line, right? You can say int I equals 0, and then len, and then let's say count equals 10, etc., right? What this means is that we are doing 3 lines of code. Int I equals 0, we define a variable of type I, integer I, and we are initializing it. But then the next one is we're just declaring, not defining, declaring a variable len. We're not initializing it, and the compiler will initialize it to 0. And the third one is int count equals 10. So this is called a compound statement, compound initialization statement, right? Or compound declaration. We're declaring 3 variables on the same line, separating them with comma, and then we are initializing 2 of them. But you cannot do, for example, var here, and you can guess why, because you can if you initialize them, var works, right? The problem is that you might not initialize one of them or a couple of them, and then the compiler has no idea what the type here is going to be. That's why they decided not to allow var for compound initialization or compound declaration, because this is going to be equivalent to saying that var int equals 0, I equals 0, which is valid, which is fine. Var len, var count equals 10. So the second one is not valid, and this is a compiler alone. That's why you cannot use var in a compound assignment, just like what we did in the for loop, right? It's not allowed just because You might not initialize any of them because Java doesn't force you to, in a compound declaration, doesn't force you to initialize them, right? You just have to declare the type of the variables you're intending to use. And then if you use var, then you might not initialize any of them, and that's a problem for the compiler. That's why they decided not to allow this. Even if I initialize this, it's still not allowed. So var is definitely not allowed in the context of compound declaration. You have to specify the type by itself. So note that on the two previous examples, you have used var to declare a variable in a for statement and in a try with resources statement, right? Those two statements are covered later in the course. If you're not familiar with try with resources or the for loops, we will cover it in later. Restrictions on using var. And again, the main restriction is it's used in the context of local variables. There are restrictions on the use of var type identifier. And we said that in C++, if you're familiar with the auto keyword, auto is a keyword in C++, and you can use it pretty much anywhere as long as the compiler can deduce some sort of type for the auto. The compiler does that, and you can use it for the return type of functions, the parameter type of functions, anywhere, as long as the compiler can deduce that. But Java decided to put much more restriction on the automatic type inference. You can only use it for local variables. So you cannot say in a class, you cannot say, and I think I showed this for the fields of a class, you cannot say var, let's say count equals 10. This is a field, non-static field or member variable, but then you cannot use var, and the compiler tells you var is not allowed here. You cannot use it in a global context of a class. That's not allowed. Remember, in Java, we don't have a global namespace. When we say global scope, everything has to be inside a class. That's why when we say the global scope, it means the global scope of a class. You cannot define a variable outside the scope of a class, right? This is not allowed because there is no global scope in Java, unlike C or C++. So there is no global scope in Java. I want you to really understand this concept. In Python, in C++, in C, you always have some sort of global scope, which is not limited to the scope of any object or any class. But in Java, everything has to be limited to the scope of a class, right? And local variables declared in methods, constructors, and initializer blocks. These are fine. Var cannot be used for fields, which means static or non-static member variables, not for method or constructor parameters. So we already saw that you cannot do this with method. You cannot say var a here, for example, because it's not allowed. You have to specifically declare the type. And then same with constructor, because the constructor of the class is just a special method and it follows the rules that you have to follow for methods, right? That's why if var is not allowed for the parameters of methods, it's also not allowed for the parameters of the constructor. The compiler must be able to choose a type when the variable is declared, and that goes with this thing. When you declare a variable, you say var v1, for example, the compiler has to be able to deduce the type. That's why you cannot leave it uninitialized when you use var, because the compiler has no clue what's going on. The compiler must be able to choose a type when the variable is declared. Since null has no type, the variable must have an initializer, which means I cannot say var v1 equal to null. I don't think this is going to work because, again, null means no type, but when you use var, the compiler has to be able to deduce a type. That's why you kind of need to be able to either some sort of initialization must happen, some sort of valid statement on the right hand side that has some sort of type. All right. Following these restrictions, the following class does not compile. So public class user, private var name. Obviously, we're using var with a field of a class, which is not allowed. Even if it's initialized, they decided not to allow that because it may cause confusion. Because using var as type identifier either for fields or the parameters of the constructor or even a method, this is not allowed. So a compilation error here, a compilation error here. As type identifier is not possible for a field or a member or a method parameter. The same goes for the following code. So we are the declaration is okay, the return type is not var, so everything but var greetings, this is not allowed because when the compiler tries to compile this line of code, it doesn't know what the type of greetings is going to be, and Java compiler is very defensive, saying that okay, I don't know, that's a compilation error, go ahead and fix it, right? Now in C++ this might work. If you use the auto keyword, the compiler takes a note of this variable and says, okay, if in the next lines of code I can't figure out what the type is going to be, that's fine with me. That's how the C++ compiler probably is going to think. Otherwise it throws an exception or a compilation error. But Java decided to be more restrictive about this. In that case, the compiler cannot guess the real type of this message. I mean, it's not message, this is a typo in this website. It's actually the greetings variable because you're using var, right? Because it's not initialized. All right, this was the discussion on var. It's relatively easy. It's very handy to use in most cases when you're trying to iterate through a list or something. You don't really want to figure out what the type is. You just want to quickly go through them and print them to the console, write them to a file or whatever. So it's very handy in those cases. So I hope you enjoyed this lecture. Please stay tuned and I'll see you in the next one.